Welcome to High Performance Pilot, where together we'll discover the secrets to improving our operational performance and so become more effective pilots. To achieve this, we're going to examine the required skills, knowledge and attitudes, collectively known as the Core Competency Matrix. I'm David Summers, and in this episode we explore knowledge of limitations and systems along with a thorough understanding of their interactions, a behaviour within the competency of knowledge. We'll examine what it is, why we need to be proficient in it, and finally, how we are going to achieve it. The core competencies should not be seen as 9 individual elements. Effective operation requires them to be used together, effectiveness in one being dependent on effectiveness in the others. They are all interconnected. Knowledge forms the foundation on which pilots and other aviation professionals build their expertise in order to ensure safe and efficient operations. From aircraft systems to meteorology, human factors to emergency procedures, the knowledge required is extremely broad. As well as possessing good knowledge, it is important to know where to find knowledge and to ask questions if you don't have it. Possessing good knowledge and the ability to find it underpins effective leadership and teamwork. An essential behaviour within this competency is knowledge of limitations and systems, along with a thorough understanding of their interactions. So what does it mean? Practical and applicable knowledge of limitations and systems refers to the understanding and ability to effectively work within the constraints and boundaries set by various factors in our industry. This includes comprehending the limitations of equipment, aircraft, regulations, procedures, and human factors. It also involves understanding the numerous systems we interact with each flight, such as flight management computers, computer applications for flight planning and mass and balance, and all of our aircraft systems. Limitations are inherent in every aspect of aviation. Aircraft have weight and balance limits, performance limitations, and operational restrictions. Human factors introduce limitations related to human performance, decision-making, and workload management. Regulations and procedures establish boundaries for safe and legal operations. It is crucial for us to be aware of these limitations and work within them to ensure the safety and efficiency of aviation operations. Systems in aviation encompass a wide range of interconnected components and processes. These systems can be mechanical, electrical, hydraulic, or computer-based, and they work together to enable flight. Understanding the interaction between these systems is essential for diagnosing and resolving issues, as well as for making informed decisions during critical situations. An in-depth knowledge of systems allows pilots to anticipate potential failures, troubleshoot problems, and optimize performance. Now let's look at why practical and applicable knowledge of limitations and systems is important. Firstly, safety. Aviation operates within a highly regulated, safety-orientated framework. Practical and applicable knowledge of limitations and systems ensures that pilots can identify and mitigate risks effectively. Understanding the limitations of equipment and systems helps prevent accidents and incidents, as well as ensuring compliance with safety standards and regulations. Secondly, efficiency. By having a comprehensive understanding of limitations and systems, pilots and other aviation professionals can optimize the performance of equipment and systems, resulting in improved efficiency. This knowledge allows for better decision-making, planning and resource allocation. It also enables us to identify areas where improvements can be made, reducing costs and enhancing productivity. Thirdly, problem solving. In our industry, unexpected challenges and malfunctions can arise at any time. Practical and applicable knowledge of limitations and systems equips us with the necessary skills to diagnose and resolve issues effectively. This knowledge helps in troubleshooting system failures, identifying alternative procedures, and making informed decisions under pressure, ultimately contributing to timely and effective problem solving. And finally, continuous improvement. Aviation is constantly evolving with advancements in technology, regulations, and operational practices. Having practical and applicable knowledge of limitations and systems allows us to adapt to these changes more easily. It fosters a culture of continuous improvement where we seek to enhance our understanding of limitations and systems to stay up to date with the best practices and industry standards. So that's the what and the why. Let's now gain an understanding of how we achieve proficiency in this behaviour. Education and training. Developing practical and applicable knowledge of limitations and systems begins with a strong educational foundation. We start with our commercial pilots exams covering a wide variety of topics and continue from there as we progress through our careers, gaining subsequent licenses and aircraft class and type ratings. Hands-on experience. Practical experience is crucial for gaining a deep understanding of limitations and systems. By actively engaging with the physical aspects of aviation, we can develop a more intuitive understanding of how limitations and systems interact. Continuous learning. Staying updated with the latest advancements and research in aviation through engaging in self-directed learning and reading aviation literature allows us to stay abreast of emerging trends, technologies, and best practices. Collaboration and communication. Aviation is a highly collaborative industry, and effective communication is vital for developing practical and applicable knowledge of limitations and systems. Engaging in discussions with colleagues, subject matter experts, and other industry professionals fosters a deeper understanding of various perspectives and experiences. Sharing knowledge and experiences through recurrent ground school and simulator sessions also enhances our individual and collective learning and promotes a culture of knowledge exchange. Our industry has moved to a threat and error management model, where we seek to operate with knowledge of the threats involved in our operation and therefore allow us to avoid or mitigate them. So before moving on to summarising the behaviour of knowledge of limitations and systems, along with a thorough understanding of their interactions, we'll take a look at some of the threats produced if we are not effective and proficient at it. Safety hazards. Lack of knowledge about limitations and system interactions can lead to unsafe practices, which may result in accidents, incidents, or near misses. Increased risk of errors. Insufficient understanding of this behaviour can contribute to human errors, such as misinterpretation of data, improper decision-making, or incorrect execution of procedures. Reduced efficiency. Inadequate knowledge of system limitations can hinder effective resource allocation, operational planning, and coordination, leading to decreased efficiency in aircraft operations, maintenance, or scheduling. Increased maintenance costs. Insufficient knowledge of system limitations may lead to maintenance input, resulting in increased costs, frequent breakdowns, or premature component failures. Reputational damage. Lack of knowledge of limitations and systems can harm our reputation and that of our airline, along with eroding trust amongst stakeholders, customers or regulatory bodies. Ineffective decision making. Without a thorough understanding of this behaviour, we may make suboptimal decisions leading to compromised operational outcomes or unnecessary risks. Inability to adapt to new technologies. As aviation systems and technologies evolve, a lack of understanding of their limitations and interactions can impede the successful integration and utilisation of new technologies, limiting innovation and progress in the industry. It is crucial for us to continuously update our knowledge and demonstrate a thorough understanding of limitations and systems interactions to mitigate these threats and ensure safe and efficient aviation operations. Here's a simple in-flight example that demonstrates this behaviour. The crew are conducting their briefing for their arrival and approach to destination. The wind is within limits but gusting and varying in direction. In this scenario, the crew's knowledge and understanding of the limitations and systems interactions come into play. Firstly, knowledge of limitations. The crew understands the functionality and limitations of the autothrottle system. They know that while the autothrottle can provide precise speed control in calm conditions, in gusty conditions it is slow to react. They are aware of the potential need for overriding the autothrottle with manual thrust adjustments to maintain a stable approach at the correct approach speed. Secondly, understanding system interactions. The crew recognises that by disarming the autothrottle, they will disable the autopilot go-around function, which in turn would increase workload if a missed approach is flown. Thirdly, applying knowledge in practice. The crew decide to fly the approach with the autothrottle active whilst using manual thrust inputs to enable quicker responses to speed changes. This will simultaneously protect the approach stability and enable an autopilot go-around if required. By showing proficiency in this behaviour, the crew demonstrate their knowledge of limitations and systems, along with an understanding of their interactions. They make informed decisions based on their understanding of the aircraft's capabilities, limitations, and the effects of environmental factors. This behaviour ensures safe and effective operation of the aircraft in a challenging situation. In conclusion, practical and applicable knowledge of limitations and systems is a fundamental behaviour within the competency of knowledge. By understanding the constraints of aviation operations and the interactions between systems, we can ensure safety, enhance efficiency, solve problems effectively, and contribute to continuous improvement in the industry. Key takeaways. Proficiency in this behaviour requires an understanding of the limitations of equipment, regulations, procedures, and human factors. Systems knowledge allows for effective troubleshooting, decision-making, and optimization of performance. This behaviour ensures safety, efficiency, and enhances problem-solving. Education, hands-on experience, continuous learning, and collaboration are key to developing this behaviour. These podcasts have an ultimate aim: to stimulate interest in the core competencies and inspire you to seek them out and apply them to further improve your effectiveness as a pilot. High Performance Pilot. Each week, one behaviour from one competency. We will break it down and provide tips and advice on how to make it a strength in your toolkit. Join me next week. If you wish to contribute or provide any feedback or ask a question, please email me at david@sim2sky.com.